Hi students, we are now ready to graduate from direct current to start talking about alternating current. So far in all the circuit analysis we've been doing, we've been using direct current or DC. And for DC, if we were to plot our signal as a function of time, we would just have some constant voltage like 12 volts or something like that. And as time goes on, it's not going to vary at all. So it's just this constant flat function. But for alternating current, we have a change as time goes on. So for alternating, this can be something like we could have a direct current for a while, and then we could have zero. We can have a direct, zero, something like this. So this would be, let's say this is at like a constant 5 volts or something like that. You'll notice it's actually a piecewise function. So this is like piecewise DC. And we can also call this a digital signal because it's either on or it's off and it alternates at a constant period. And we might also call this a square wave. So this is square wave AC signal, looks like this. We're going to be using sinusoidal signals, and they have this sinusoidal shape like this, and this is going to be sinusoidal. And it turns out that if we have a signal like this, that means that our voltage or our current is going to be varying sinusoidally. And we can actually make any periodic signal from a sum of sinusoids, which I'll talk more about when you get into Fourier analysis. But it's really useful actually to be studying alternating current when it's in sinusoidal form like this. So this is a sine wave. This would be a square wave. You guys might also see there's like these sawtooth waves that look like this. So this would be sine wave and sawtooth, or sometimes it's referred to as a triangle wave. So these are all examples of alternating current. So let's kind of zero in on the sinusoidal form. So suppose we have a voltage an AC voltage in sinusoidal form. So the way it's going to look is we have this sinusoidal function like this. We have a peak here. The distance from the zero axis to this peak is going to be our maximum voltage, Vm. And then the time it takes to complete one cycle of this is going to be the period. So from here to here is going to be period t. Now the formula for this is voltage as a function of time is going to be the maximum voltage times the sine of omega t. Now this omega here is going to be the frequency, but it's in radians per second, so this is angular frequency. Let me just write all these out for you, where Vm is that's shorthand for Vmax. So this is going to be the amplitude of the voltage signal. And then omega is the angular frequency. And the unit is radians per second. And then big T is the period, and I have it labeled here on the graph. And frequency is 1 over period. Now, if you have frequency denoted by F as opposed to omega, then this frequency is going to be in hertz. Okay, the definition of hertz is cycles per second. Okay, but this is radians per second. So to convert between frequency and f and omega, convert between f and omega looks like this. Frequency is going to be angular frequency divided by 2 pi. Okay, so you might need this conversion if you're given a problem where you know the frequency in cycles per second, but you want to put it into this radian form and you need to find out what the omega is. So you would just take your frequency, multiply by 2 pi, and that would give you the omega. Okay, so then similarly, a current in sinusoidal form is going to be current as a function of time is the max current times sine of omega t, okay? Where this is the angular frequency, this is our independent variable t, and I max is the maximum amplitude of our signal. So if it has a shape kind of like this, we know that the distance from here to here is I max, and then we can also find the period. So if from here to here is 1 cycle, we know that given this omega, if we do omega divided by 2 pi, that's going to give us the frequency. And then to find frequency, so frequency is 1 over period. So to find period, so this distance from here to here is the period would be 1 over the frequency. So in other words, this would be 2 pi over omega. Okay, so now we have learned how to kind of discern some information about this sinusoidal signal. And in the next video, I will tell you what phase shift is.